Okay, we start. Today's of date is of 3/7/2020. What you have seen yesterday? You have seen yesterday that is first introduction, and second is vision and mission of the institute and department, and the third is PEOs, next PSOs. After that, you have seen the overview of syllabus. In that syllabus, what you have seen the code is of EP413, that is satellite communication. And there are two sections in this. One is section 1, section 2. Section 1 is of 3 units and the section 2 is of 3 units. And next we have seen the basics of communication system. Is it audible? Can anyone unmute and tell me?
Yes, sir.
Oh, okay, okay. Okay. Okay, I will ask the question, that is what is meant by communication?
Exchanging information from one place to another.
Exchanging information from one point to multiple points. Okay. Keep in mind that is from one point to multiple points, because we are using the communication from the satellite. It is going to cover a longer distance communication. So we are using for one point to multiple points. Next, what you have seen, we have seen after the communication system, you have seen the one block diagram, that is the block diagram of elements of communication system. Which are the elements of communication system? Elements of communication system.
Sender,
Information source,
channel,
receiver, transmitter.
Input transducer, transmitter, next channel,
channel.
receiver and output transducer. Okay. Is it there? Nikita Pulare. What is the actual function of transmitter? Pulare? Nikita from a division. Okay, so please coming. Because my mobile is here, I have to admit everyone. Okay, what is? Next button. What is the function of transmitter? No one. You're not responding from anyone. Dhanure. I have muted all one division device, that is PC. I am talking from this mobile. So it is echoing. Dhanure is the response. Amit Dhanure.
Yes, sir.
What is the actual function of transmitter?
For given information, it processes something and makes it capable for transmitting for long distance.
Transmitting for?
For a long distance.
That is not a function of transmitter, Dhanure. Which are the components present in the transmitter for amplification? For amplifying the signal. Modulation, encoding, filtering. These are the components present in transmitter. it is echoing more. Okay, we'll check. Today we'll listen like this. Okay, next is what you are saying. Just you have to take down this. Okay, everyone has to take this diagram. Write down as a notes. I'll give you 2 minutes. First. Take this block diagram of communication system. Okay. I think you are written. Next is what? So send this input transmitter channel. So point number 1 is what? Introduction to satellite communication. In this introduction to satellite communication is, this is the first point. The first point of satellite communication. What is this? The satellite communication is nothing but the satellite communication satellites to bring the world to you anywhere and anytime. That is the function of satellite communication. If you are present anywhere, is it audible now? Because I am using the PC system. So it is audible. PC is muted already. Just a minute. I muted everything. Okay, wait, I will present from here. So voice is echoing because of this. I have muted one PC mic, but it is still it is echoing.
Sir, your
Ah.
voice is not audible, sir.
It is audible, but it is echoing, no?
There is some echo problem, sir.
Huh?
Echo problem.
Echo problem is there. I have muted the PC mic, but Not, again it is coming. Just a minute. I'll end this. Okay, is it audible now?
Yes, sir.
Okay.
Yes, sir. Yes, audible.
Okay, okay. I'll take it from mobile itself. Okay. Just a minute. Let's start recording. Okay. Is it visible?
No, sir.
Hello?
No, sir.
Is it visible?
No, sir.
No. I started presenting.
No, sir.
Just a minute. Now?
Yes, sir. Now it is
Visible, visible, sir.
Yes,
Okay,
sir.
okay.
Now
Okay.
visible.
Okay. Let's start with point number 1, that is introduction to satellite communication. You have seen what is meant by communication. The communication is nothing but exchanging information from one point to multiple points. That is, the points are different and multiple points are different. Whatever the information is sending from one point to another point, we require this communication system. This communication system is always present in that satellite subsystem. The parameters or components present in satellites are satellite communication system. What is the actual function of this satellite communication is? The communication satellites bring the word to you anywhere and anytime. That is nothing but what? At any time you want to make a call, you want to send any images, you want to send any pictures. That is at any time, or if you are anywhere in the villages, in the urban area, in the rural areas, that is the actual function of satellite communication. That is the function of satellite communication. And next, just a minute. And what is the actual history of satellite communication? The history of satellite communication is actually where it is coming from, the satellite. The satellite communication began in October 1956. The first satellite has launched by Russia in the year 1956. That is the name called as Sputnik. The name is of Sputnik. You have to write this name. You have to write in your notebook. That is, the first satellite has been launched by the Russia. The name is Sputnik. That is one. It is the first artificial Earth satellite, and it sparked the space race between United States and Russia. It is the first man-made satellite that is sparked between the United States and United States and Russia. Once the Russia has been launched, again the Sputnik 1, that is the first satellite launch, carried only beacon transmitters, did not have communication capability. There is no communication. That is a beacon transmitter. The function of this beacon transmitter is to receive the signal and transmit the signal back to the station. That is only the function of beacon transmitter. There is no communication is required. That is, communication system is not present in that Sputnik 1. So after that, what has done, the USA has launched one more satellite, that is Explorer 1, in the year 1958. The first satellite successfully launched by the US, that was Explorer 1 on January 1958. Once the Russia has launched the first satellite, that is Sputnik 1, after an year, immediately the USA has launched that is one more satellite, that is 1958, that is Explorer 1. That is the first satellite launched by Russia is Sputnik 1, and the USA has launched the satellite by Explorer 1 in the next year, that is 1958. And the voice has been recorded, recorded the voice. So the US president has recorded, who recorded Christmas message that was transmitted back to the Earth from SCORE satellite in the December 1956. That is successfully done through the USA. And next is the world first commercial communication satellite was Early Bird, that is called as Intelsat 1. Commercial satellite communication, once the communication has started, they are using that communication system as commercial communication. That is the name has given, that is Early Bird, that is Intelsat 1. You have to write the important points, which is the first satellite launched by Russia, which is the second satellite launched by USA, and the third satellite that launched for communication. You have to write the important points in that. So that the world first commercial communication, that is for sending any voice signal, sending for any video signal, sending for any audio signal, sending for any images, to take the images of the Earth station. That is, everything will be done by this Early Bird Intelsat 1. That is once started, that is through commercial communication satellite. That the satellite name is Early Bird, that or it is called as Intelsat 1. It is launched in the year 1965, April 6, and placed in commercial services after moving into the geosynchronous orbit. There are mainly different types of orbit. One is low Earth orbit, medium Earth orbit, and high Earth orbit. And medium Earth orbit, we are using the geosynchronous orbit, and the distance is of 22,300 miles above the equator. What is meant by equator? Actually, the equator is nothing but what? When the satellite is revolving around the Earth, it has to maintain its 360 degree. That is the equator. It has to maintain its 360 degree. It is nearer to the oval shape. That is like oval shape, egg shape. That is to maintain. It has to be revolving around the Earth in a 360 degree. That is called as equator. When the satellite is revolving around the Earth, it has to maintain its orbit. Orbit is nothing but that is a path. It has to maintain its equator, that is above the Earth from the satellite. And the actual weight of that satellite, the Early Bird satellite, is of 36 kg, and the frequency that they are using is of 6/4. What is 6/4 gigahertz? You have seen already in mobile communication. 6 is of uplink and 4 is of downlink frequency. 6 gigahertz is for uplink frequency and 4 gigahertz for downlink frequency. That is of C-band. Frequency is of C-band. The transponders, each with the bandwidth is of 25 megahertz. The each width is nothing but what? For uplink, we are using the frequency band of 6 gigahertz with the bandwidth of 25 megahertz, and the 4 gigahertz with the bandwidth of 25 megahertz. And yesterday, I told you what is the actual meaning of transponder, what is the definition of transponder. The function of transponder is to receive the signal from the Earth station, and it converts its frequency and send it back to the Earth station. That is the actual function of transponder. The minimum transponders present in a single satellite is of 10 to 50 transponders. In a single satellite, the total transponders present are 10 to 50. You have to remember this transponder definition. Okay? And this, whenever, always this uplink, the frequency is always high compared to the downlink frequency. Why? Because the uplink frequency is always required the higher frequency, because whenever you are sending any signal to the satellite from the Earth station, we require the more bandwidth, that is more frequency band, because we are sending the baseband signal without any modulation. We are sending the baseband signal without any modulation to the space, that is satellite. Once that signal has reached to the satellite, the actual function of satellite is to convert that signal to the original signal, to the which at the receiver end with a frequency limited, that is going to reduce the frequency, that is of 4 gigahertz. You have to remember this. Uplink and downlink. What is meant by uplink? It is from Earth station to satellite, that is uplink, and the downlink is from satellite to Earth station, that is of downlink. We are using 6 by 4 gigahertz. And early bird, that is the first commercial satellite has launched, that is early bird Intelsat. That is early bird didn't have a battery. It is operated only on the solar panels. It is not installed a battery at that time. They have installed only the solar panels. Through solar panels, the satellite is going to access the energy from the sun. That is not sufficient for the solar panels to getting the energy from the sun and operated satellite. So this is, after that, once the early bird has launched, after they are going to launch one more satellite. When they are launching the one more satellite, they are going to started installing the batteries with respect to solar panels. That is, early bird didn't have a battery and work only when it is solar panels were exposed to the sun. Only solar panels are going to grab the energy from the sun, and that energy will be used to operate the satellite. They didn't have battery. When this is solar panels are operated, actually when there is a sun is given the sun rays, that is going to access the energy. When there is no sun, there is no sun rays, so it is can't access the energy. So that is going to difficult for the satellite to operate. So they are going to use the batteries. When the solar panels is not able to access energy from the sun, they are going to use the battery. The battery will start operating the satellite when the solar panels are absent for accessing the energy. This is the next. What is satellite? Astronomic terms, a satellite is a celestial body that orbits around a planet. A satellite is a celestial body. Celestial is nothing but what? It is a heavenly body. It is a heavenly body that orbits around a planet. Planets are nothing but your Earth, Moon, or the Sun. For example, Moon is a satellite of the Earth, and Sun is a satellite of the Earth. That is nothing but, this is one of the examples. It is a heavenly body which is revolving around the Earth, Moon, or a Sun in an elliptical orbit or circular orbit. That is called as a satellite. You have to remember this definition. It is a heavenly body which is revolving around the Earth, Moon, or the Sun in an elliptical or circular orbit. That is called as a satellite. And next point, in aerospace terms, a satellite is a space vehicle launched by humans or orbits around the Earth or another celestial body. It is whatever the scientists are going to launch the satellite, that satellite is going to maintain its orbit. It is going to maintain its path. It has to maintain its path as a heavenly body. Next, what is meant by communication satellites? It is a microwave repeater in the sky that consists of a diverse combination of one or more components, including transmitter, receiver, amplifier, regenerator, filter on board computer, multiplexer, demultiplexer, antenna, and waveguide, etc. These are all the components are present in this communication satellite. And it is a microwave repeater. What is meant by microwave repeater? It has to receive the signal. It has to receive the signal, amplify that signal, remove the noise present in that signal, and sending it back to the Earth station. For that, we require some of the functions or some of the components. Those components are, we require transmitters to send the signal, receiver to receive the signal, amplifier to amplify the signal, and you have to regenerate that signal. For that, we require filter to remove that noise. You have to increase that signal, we require multiplexer. Again, we have to demultiplexer, you have to regenerate that signal. We require antenna for receiving the signal, for amplifying the signal, and some of the waveguides we require whatever the signal is receiving. And next, a satellite radio repeater is also called as transponder. One of the definition is called as a satellite radio repeater. That is also the same definition of transponder. Repeater is nothing but what? It is always repeating. Whatever the signal you are receiving from the Earth station, it has to change its frequency and send it back to the Earth station. That is always repeating the signal. This is usually combination of both transmitter and receiver. At that time, we require both the transmitter and receiver for sending the signal and for receiving the signal. Is that? Okay. Next. This is the class notes actually. The satellite communication is also called as worldwide communication. Okay. This is actually the meaning of satellite communication is also called as worldwide. It is using all the communication is going through only the communication system only because of satellite, that is worldwide. Whatever you are watching the live cricket or speech of any Modi's speech, that is only because of satellite. And the operating frequency range is of 1 gigahertz to 50 gigahertz. Operating frequency range is of 1 gigahertz to 50 gigahertz. And whatever the techniques we are using in satellite communication, they are using in the olden days, they are using frequency division multiplexing. Olden days, whenever they are launching the satellite, first satellite, that is Sputnik 1, that is frequency division multiplexing they are using. Whenever they are parallelly launching the number of satellites, they are started using TDM technique, that is time division multiplex technique. The technique used in the olden days is frequency division multiplexing, and nowadays they are using the technique is time division multiple access. That is actual technique they are using. And this is the definition. You have to write this, everyone has to write this. Satellite is a heavenly body which moves around the Earth in elliptical or circular orbit. Elliptical is nothing but what? It is in an oval shape. This is egg shaped. Whenever they are launching the satellite, they have to fix the orbit first. Once the orbit has been fixed, the satellite has to reach that orbit. It can't change the orbit. It has changed. Again, you have to monitor through Earth station and they have to correct its orbit. Orbit is nothing but what? That is a path. It has to follow that path. Satellite is a heavenly body. Okay, that is the weight is very high. That is, satellite is a heavenly body which moves around the Earth or Sun or the Moon. You can take that is Earth, Sun or the Moon in elliptical or circular orbit. That is in oval shape or in egg shape or in circular. It is nothing but in a 90 degree shape. That is called as satellite communication. There is one diagram over here. You have to take down that diagram. There is the Earth and it is equator. This line is called as equator. That is a big circle. That is equator. There is Earth. There is a satellite. In this, when the satellite is revolving around the Earth in an elliptical orbit, it has to use the two forces. It has to use the two forces. One is gravitational force and one is centrifugal force. Gravitational force and centrifugal force. The satellite has to be operated on two forces. One is gravitational force and one is centrifugal force. What is meant by gravitational force? When the satellite is revolving around the Earth, it has to be grabbed towards the Earth. That is gravitational. Gravitational force is nothing but pulling the satellite towards the Earth. It has to pull the satellite towards the earth, there is a gravity. And one more function of centrifugal force. It is to pull the away from the earth. The satellite has to pull away from the earth. That is centrifugal force. Gravitational force and centrifugal force are different. Gravitational force has to pull the satellite nearer towards the earth. It has to pull away from the earth. That is actual function of two forces. One is gravitational, one is centrifugal force. When the satellite is revolving around the earth. If satellite is able to rotate in its orbit, orbit is nothing but what? Path. You have to remember this. I will ask you the question again tomorrow. When the satellite is revolving around the orbit, that is to maintain the path, always this gravitational force is equal to the centrifugal force. Which what? Whenever it wants to maintain its path, maintain its orbit, always this gravitational force is equal to the centrifugal force. What is the actual equation of gravitational force? How it is acting the satellite? The gravitational force, that is Fg, is equals to, so to write this, m dot g into r divided by small r whole square. Fg, that is gravitational force, is equals to m comma g into r, capital R, divided by small r whole square. What is meant by m? That is m is mass of the satellite. So mass of the satellite, that is how much weight of this mass of the satellite. And the g, earth gravity. Gravity of the earth is the fixed, that is the constant value, that is 9.8 meter per second square. You have to write this equation. Whenever I explain, you have to write this equation. That is very important equation. The gravitational force is equal to m dot g dot into r divided by r whole square. Capital R is different, small r is different, that is whole square. M is mass of the satellite, G is earth gravity. The earth gravity is equal to 9.8 meter per second square. And the capital R is radius of the earth. Radius of the earth. The value is of 6370 kilometers. That is also constant value. Capital R, that is the radius of the earth, is equal to 6370 kilometers. And the small r is nothing but the distance of satellite from the center of earth. Distance of satellite from the center of earth. Whatever the distance from the earth to satellite, that can be calculated by small r, and the capital R is the constant value, that is radius of earth. That is gravitational force. And one more force is there, that is centrifugal force. The centrifugal force, that is Fc, is equals to m dot r dot omega square. Centrifugal force Fc is equals to m dot r dot omega square. What is omega? Angular velocity. Omega is equals to what? Angular velocity is equals to 2 pi f. Omega angular velocity is equals to what? 2 pi f. F is what? Frequency of rotation of the satellite. Frequency of rotation of the satellite. You have to write this. You have to take this diagram, write the definition, and take this equation. Gravitational force, that is Fg, is equals to m dot g into r divided by r whole square. M is mass of satellite, G is earth gravity, that is 9.8 meter per second square. Capital R is radius of earth, that is 6370 kilometers, and the small r is distance of satellite from the center of earth. And one more force is centrifugal force, that is Fc, is equals to m dot r dot omega square. Omega is nothing but angular velocity, that is velocity is nothing but the speed, that is equals to 2 pi f. So f is nothing but frequency of rotation. Always the satellite has to maintain its orbit. Always these two forces will be equal. The centrifugal force is equals to gravitational force, and the gravitational force is equals to centrifugal force. You have seen the two equations, and say this. Condition is that The satellite is able to rotate in its orbit. The condition is that the satellite is able to rotate in its orbit. The condition is what? The gravitational force is equal to what? Centrifugal force. So what is the equation of gravitational force? M data, comma, G into R divided by R whole square and is equals to M dot R dot omega square. In this equation, what? M and M both are get cancelled. Remaining is of G into R square divided by small r square and equals to R dot omega square. And this G comma R square, you have to take that small r at the right hand side, that it becomes G comma R square equals to R cube dot omega square. You have seen that is omega is nothing but what? Angular velocity. We have to calculate the small r. What is small r? The distance of the satellite from the center of the earth. You have to calculate the distance of the satellite from center of the earth. That is small r. Capital R is radius of the earth. So small r, that is the distance of satellite from the center of earth. R is equals to G comma R square divided by omega is nothing but what? 2 pi f whole square into 1 by 3. That is R cube is there. That is you have to use 1 by 3. In this equation, what you have seen? The previous equation, G is constant and R are constant. There is a constant value. G is equals to, that is 9.88 meter per second square. And R constant, that is 6370, I think. If these two are constant, the distance of satellite from the center of earth is always depends on the frequency. Got it? Distance of satellite from center of earth is only depends on its frequency. Okay? Got it? Anyone unmute and tell me?
Yes, sir.
Okay. You have to remember these two equations and you have to write down. I'll give you 2 minutes. Just write this equation. This is very important. Satellite is a heavenly body which moves around the earth in elliptical or circular orbit. That is called as satellite. You have to take this diagram. Where 2 forces are acting on this. One is gravitational force, one is centrifugal force. Actual meaning of gravitational force is to pull the satellite towards the earth. Pull the satellite towards the earth, and the centrifugal force is to take the satellite away from the earth. It is acting against the gravity. That is a function of centrifugal force. And the next point is, satellite is able to rotate in its orbit only when Fg is equals to Fg. Fg is equals to Fc. Write down this equation. Fg is equals to m dot v dot r divided by r whole square. You have to remember this. Mass of satellite, earth gravity 9.8 meter per second square. R is radius of earth 6370 kilometer, and small r is distance of satellite from center of earth. And similarly for one more force, that is centrifugal force. Fc is equals to m dot r dot omega square. Tomorrow I will ask you the question, keep in mind. And omega is equals to what? Angular velocity. That is 2 pi f. That is, f is nothing but frequency of rotation. Next, condition is that satellite is able to rotate in its orbit. Always the gravitational force is equals to Fc. You have to substitute those equation in this. Fc is equals to Fc. Fg is equals to Fc. So we'll get the final equation, that is r small r, that is center of satellite from the distance of satellite from center of earth. That is r equals to g dot r square divided by 2 pi f whole square into 1 by whole raised to 1 by 3. G is constant, that is Earth gravity, and r is constant, that is radius of Earth. Always this radius, that is distance of satellite from center of Earth, that is small r, it always depends on its frequency. Okay. Next point, how satellite works. How the satellite works. This is one of the important example for how satellite is going to work. There are two medium, one is transmitting, one is receiver. Transmitting station on Earth, receiving station on Earth. This is satellite is present at the space. Whatever the information you are sending from transmitter side from the Earth station, that the frequencies of uplink, the frequencies of 6 gigahertz. That signal is reached to your satellite, and this satellite, the transponders are present. Actually, the function of transponder is to receive the signal, changes the frequency, amplify it, and send the same signal back to the Earth station at the receiver end. And the frequency that is called as link is downlink. That is the frequencies of 4 gigahertz. Uplink is from Earth station to satellite, and the downlink is from satellite to Earth station. This is how actually the satellite works. This is the example of this. The actual example, that is, I have explained in this. The two stations on Earth wants to communicate through radio broadcast, but are too far away to use conventional means. Whatever the two stations we are using, that is the transmitter and one is receiver, they are too far away from the satellite. And the two satellite stations can use the satellite as a relay station for their communication. There is a delay between these two satellites through transmitter and receiver. And next, one Earth station transmits the signal to the satellite at uplink frequency. And uplink frequency is the frequency at which Earth station is communicating with the satellite. Same thing, whatever the signal you are transmitting from transmitter to the satellite, that is uplink. That uplink frequency is called as, or that frequency is communicating to the satellite. And the satellite transponder processes the signal, sends it to the second Earth. Second Earth is nothing but that is the receiver end. Satellite transponder processes the signal and sends it to the second Earth station at another frequency called downlink. The frequency of transmitting is different and the frequency of receiving is different. That is called a transponder, that is for downlink. We are using the frequencies of 6 gigahertz for uplink and 4 gigahertz is for downlink. Okay, we'll see tomorrow, that is advantages of satellite and disadvantages of satellite. You should be ready. I will ask you question at any time. Okay. Is there any question to ask? I will send you the PPT. There is a link, just click on the link. Hello?
हाँ सर.
more बात कर देंगे. Okay. Today we'll leave. We'll continue tomorrow. Okay.
Okay sir.
Ashwini Patil Margadinen.
Yes sir, I will send you on WhatsApp.
Okay. बच्चे भूषण